Okay, good evening. This is Venkat Ramulu, Assistant Professor, Department of Chemistry, Mallarad Engineering College, Autonomous. Today, I would like to explain about the corrosion and different factors which are influencing the rate of corrosion. Now, I would like to share the screen, and after that, we'll proceed. So, this is the topic of today, that is factors influencing corrosion. And let us see what is corrosion actually. Corrosion may be defined as the gradual destruction of metals by the chemical or electrochemical reaction with the environment. During corrosion, the metals are converted into their metallic compounds at the surface of the metal. So, simply corrosion is the decay or destruction of the metal, and this destruction is taking place by chemical or electrochemical attack of its environment, and always this corrosion is taking place at the surface of the metal. So destruction of the metal or decay of the metal or damage of the metal is simply called as corrosion. So this is causing by two types of attacks, chemical attack or electrochemical attack. And now let us see some images. So this image is clearly showing the effect of corrosion on the metal surface. So metal surface is completely corroded here. Rust formation has taken place. So this is one type of problem for the metals. And because of this problem, we are losing very, very valuable metallic material completely. So corrosion is undesirable or unwanted process. And one more image, this image is very, very clearly indicating the severity of corrosion on the metal surfaces. The metal is completely converted as rust, and that metal is not at all having any useful properties due to corrosion. Now, what are the effects of corrosion and what are the problems of corrosion? So here we have three types of problems or losses because of corrosion. Number one is waste of material. The material which is undergoing corrosion is almost waste. So metals are very valuable, but we are losing valuable metallic material because of the corrosion. So that's why waste of material takes place because of corrosion. Then economical loss. So whenever one metallic part is corroded in the industry, we have to replace that with fresh one. So because of that, economical loss will be arising. So this economical loss may be two types, direct loss as well as indirect loss. So in the indirect loss, we have shutdown possibility. The industry may shut down also. Loss of product, loss of efficiency, product contamination, and over design are the indirect losses of corrosion. Similarly, third one, environmental impact or health impact. So environment is also getting affected by corrosion. For example, let us take methyl isocyanide, very poisonous gas, which was leaked because of the rust formation in the pipes. Poisonous gas was leaked because of the corrosion only. So that poisonous gas affected the environment very badly, as well as it was affected so many people also. The health of the people was affected very, very badly because of that methyl isocyanide. So it is having different types of losses: material loss, economic loss, and environmental and health related loss is also possible by corrosion. And now let us see what are the different types of corrosions. So just now we defined corrosion is destruction of metal by the action of chemical or electrochemical environment. So what is chemical attack? So whenever the atmospheric gases attack the metal directly, then also we expect corrosion. So that type of corrosion is called as chemical corrosion or dry corrosion. So chemical corrosion always occurs mainly by the attack of atmospheric gases. And second one is electrochemical corrosion or wet corrosion. So this corrosion occurs when a metal is in contact with a conducting liquid. Whenever metal is having some contact with conducting liquid, wet corrosion is possible. Similarly, two dissimilar metals or alloys are immersed partially in a conducting liquid. Whenever two dissimilar metals are partially dipped in a conducting liquid, then also we can expect the wet corrosion. So this wet corrosion always arises by the development of anodic and cathodic parts on the metal surface. Now let us come to the factors influencing corrosion. So how rate of corrosion will be affected? So the rate and extent of corrosion depends mainly upon two factors. Number one is nature of metal. Nature of metal itself is responsible for the corrosion rate. Similarly, nature of the environment is also responsible. So the surroundings of the metal, where it is placed, those surroundings or environment plays a, an important role in the rate of corrosion. Now let us see one by one by taking some factors. First one, nature of metal. Nature of metal is very important one in deciding the rate of corrosion. So in this sequence, we have the first one, first factor, that is position in galvanic series. So if any metal is present higher or above in the galvanic series, that undergoes corrosion. If any metal below or lower in the galvanic series, that undergoes less corrosion. So position of the metal is also going to decide the rate of corrosion. If metal is higher in the galvanic series, more corrosion is possible. And second factor is relative anodic and cathodic areas. So whenever we are having smaller anodic area, the rate of corrosion will be more. So cathodic area is smaller means the anodic area is smaller means cathodic area will be larger one. So at cathodic area, what happens? The electrons get consumed. Reduction reaction takes place. So larger cathodic area always demands more number of electrons. So demand is more at larger cathodic area. To meet this demand, the smaller anodic area has to undergo more corrosion. So rate of corrosion very highly increases if the anodic area is small. Next, number three, third factor, that is purity of the metal. So whenever the metal is pure, then the possibility of the corrosion is less. The rate of corrosion will be less. But when some impurity is added to the metal, then there is a possibility of the formation of minute electrochemical cells, and the anodic part will be undergoing corrosion. So impurity always increases the rate of corrosion. Then physical state of metal. Physical state is also going to decide the rate of corrosion. So if the size of the metal is small, then the rate of corrosion is more. So if you have two sized, small size and big sized metals, then definitely smaller sized metal undergoes more corrosion than the bigger sized metal. So what is the reason for that? The dissolution or the effect on smaller sized metal will be more when compared to the bigger sized. So physical state is one of the factor. And next, number 5, fifth factor is nature of corrosion product. So we are having some different types of oxide films which are forming on the metal surface. So some are non-protective porous oxide films, some are protective oxide films. So for example, one oxide film on one metal is having pores, is having breaks, is having cracks, then definitely the underlying metal undergoes more corrosion. And for example, you take aluminum, chromium, nickel, etc. metals, these form protective oxides, protective oxide film. So that's why the underlying metal corrosion rate will be very, very less. The corrosion will be restricted due to the formation of protective oxide film on the surface. So nature of the corrosion product decides the rate of corrosion. Similarly, next property, next effect, that is solubility of corrosion product. On the metal surface, some metal oxide film is formed. If that metal oxide film is soluble in the conducting liquid, then fresh surface of the metal exposes to the atmosphere. So whenever it is exposing to the atmosphere, further oxidation and further corrosion can be expected. So solubility of the corrosion product increases the rate of corrosion. Then volatility of corrosion product. So if the corrosion product, nothing but oxide film, is volatile in nature, means it evaporates easily, then continuous corrosion takes place. At the same time, the rate of corrosion will be more. So whenever the corrosion product is soluble, whenever the corrosion product is volatile in nature, then the rate of corrosion will be more. Now let us take up the nature of environment. So environment plays an important role in rate of corrosion. So first one is temperature. As we know, as the temperature increases, the rate of reaction increases. Corrosion is also one of the chemical reaction. It is oxidation. So the oxidation rate will be increased by increasing the temperature. So temperature rise always increases rate of corrosion. Then number 2, which is very crucial, that is humidity. Humidity in air is directly related to the rate of corrosion. In a humid condition, atmospheric gases easily form electrochemical cell by which corrosion occurs to a great extent. So humidity captures the atmospheric gases like O2, like H2S. All these gases will be captured by this humidity. So because of that, electrochemical cells are forming on the surface of the metal. So the corrosion possibility is very, very high in the presence of humidity. Kabatti, humid condition is always preferring the more corrosion. Then third effect is effect of pH. So environment, nature is also going to decide the rate of corrosion. So acidic environment is more corrosive than alkaline and neutral medium. So whenever pH is less than 7, then corrosion rate will be more. If you compare the corrosion of two metals, one is placed at pH 5, second one is placed at pH 11, then definitely the rate of corrosion will be more for the pH 5 metal. So effect of pH is affecting rate of corrosion. Then fourth one, formation of oxygen concentration cell. So here we can explain by dipping one metal rod in the conducting liquid partially. So whenever the metal rod is partially dipped in the conducting liquid, some part of the metal is above, which is having high concentration of oxygen, and the lower part of the metal, which is inside the conducting liquid, is having lower concentration of the oxygen. So under this situation, the poor oxygenated, the low oxygenated part undergoes corrosion and it acts as anode. Okay, so here oxygen difference, the concentration of oxygen difference arises on the metal surface. So wherever we are having less oxygen concentration, that acts as anode and that undergoes corrosion. Next, number 5, nature of ions. There are some ions like a chloride ion, ammonium ion, etc. These ions destroy the protective surface film. Film will be always there on the metal surface. So that protective surface film will be destroyed by Cl- and NH4 plus ions. And because of this destruction of the surface film, the metal surface is again exposing to the atmosphere and undergoing corrosion. And next factor is presence of suspended particulars or compounds. Here, ammonium sulfate and sodium chloride, like salts, if present along with moisture, they act as powerful electrolyte and they definitely promote the higher corrosion. So the presence of that type of salts is always accelerating the rate of corrosion. So these are the different factors. And conductance of corroding medium. So whenever some underground or submerged structures are there, they may undergo corrosion based on the nature of the soil. Conductance of dry, sandy soil will be lower than the clayey and mineral soils. Conductance of dry soil is less and conductance of clayey and mineral soil will be more. Wherever we are having more conductance, definitely the corrosion will be more. So the corrosion rate of metallic structures is more in the clayey and mineralized soils than dry sandy soil. So these are the important factors which are influencing the rate of corrosion. Thank you.